Jai Jagandar, Namaste, welcome to my channel. Today we are going to solve the 16th question of the placement series, problem solving series that is based on arrays. This question has been asked in Amazon, MMT, Make My Trip, SAP Labs, and the difficulty level for this question is medium. So we need to rotate the array. So we are given the array and we are given the value by which we are going to rotate the array. So in the question it could be we might be asked to left rotate the array or right rotate the array. Let's assume we need to right rotate the array. So this is 1, 2, 3, 4, 5, 6, 7. That means the right part of the elements, the given value is 2. We need to rotate it 2 times. That means if we rotate it 1 time, what will happen if we rotate it towards right? This 7 will come in the beginning and this will become 7, 1, 2, 3, 4, 5, 6. 1 time right rotate. Okay. If it is given 2 times right rotate, so we need to rotate it again. Again the rightmost element will come at the beginning and all will shift towards one value. So the answer would be 6, 7, 1, 2, 3, 4, 5. Okay. So here in this question 3, 4, 5, 6, 7, 1, 2. The 1, 2, the D is 2 again. So the 1, 2 will come in the front. First 2 will come and then 1 will come and this will shift to two places. So this will become as 1, 2, 3, 4, 5, 6, 7. So now how do we solve this? So the first approach that is coming to our mind is very simple. We have been given this array. Okay. So say we have been given void rotate array and we have been n vector and ampersand a. Okay. Now we can take the, so if the size of this array is n, that means the d n minus d is this, n minus d minus 1 is this part. Okay, so if we take another array, temporary array, and we store the last two or whatever the d is there, if we store the value from n minus d, n minus d would be this is n and this is n minus 1. So this is n minus 2 and this is n minus d. So if we store the value from n minus d to n minus 1 in the temporary array in the beginning, and then we store the value from 0 to n minus d minus 1, we will get our array, temporary array in the values, this rotated values, and then we can just copy this rotated value into the original value and we can just return the original array. This is very simple. What would be the time complexity? I am not going to code this solution. This naive approach time complexity would be simple order of n. We will be traversing the loop twice. And what would be the space complexity? The space complexity would be order of n because we are taking an extra array. So I hope this approach is very clear. This is very simple, right? What will we do? We will, for example, this one, we have 2. So here we are going to copy these two values here in the temporary array from n minus d to n minus 1. We are going to copy this value and then from 0 to n minus d minus 1 we are going to copy the rest of the values and then we are going to copy the temporary array's values to the original array values and we can return it, right? But can we optimize the space complexity? We have to traverse it in order of n that we know is the array, but we are taking an extra array, temporary array. Can we optimize this? Yes, we can. There are multiple ways to solve this question. One is a GCD, and the simplest way is, there is a simple mathematical way. So what we can do, we have these values over here, right? And we have this value. We need to bring this value in the front without taking any extra space. So if we reverse this, let's do one thing. Let's reverse this array from 0 to n minus d minus 1. So here n is 7, 7 minus 2 is 5, minus 1 4, 0 to 4. Let's reverse it. So what will happen if we reverse this? This will become 5, 4, 3, 2, 1, and this will be 6 and 7. We have reversed this. First step, okay, reverse the 0 to n minus d minus 1 elements, will reverse the array. Then second, let's reverse the remaining part of the elements, right? We reverse elements from n minus d to n minus 1. Then what will happen? This same array, this would become 5, 4, 3, 2, 1. Now this would become 7, 6, right? Right? Now reverse the whole array. Reverse 0 to n minus 1. Then what will happen? This will change to 6, 7 was there. 6, 7 will come in the beginning. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This gave us the value. So 3 steps, right? Simple. What we are going to do? We are going to have a reverse function which will reverse the array from 0 to, say, we reverse the end part first, or anything is fine. So we reverse from a 0 to n minus, we have another d, the rotation in d, n minus d minus 1. So we have reversed here. Then what we will do? We will reverse the n minus d, comma n minus 1. Okay, and then we will reverse the whole array 0 to n minus 1, and this will reverse the array with this right rotation. We have just given this examples where this has worked. Let's work it out for this one. We have 3, 4, 5, 6, 7, 1 and 2, and the value of d is 2. Okay, so what we will do? We will reverse this part first. 3, 4, 5, 6, 7. So then this will become 7, 6, 5, 4, 3, and this will be 1, 2. First step. What would be the second step? We will reverse this part. So 7, 6, 5, 4, 3 would be same. 1, 2 would become 2, 1, right? And then we will reverse the whole array. So what will happen? 1, 2, 3, 4, 5, 6, 7. This is what we have done with the previous approach. The answer is matching. We have rotated this first 2 towards the right, and in this way we can rotate the array with order of n time complexity and order of 1 space complexity. I hope the question and the solution is clear. Both the approaches are clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough section of the 16th question of the problem solving series, that is rotate array. And it's given that we are going to rotate the array to the right by k steps here. As discussed, we are discussing the optimized approach, where we are solving this question in order of 1 space and order of n time. So what we are doing, we are reversing the array's first n minus k elements, and we have this reverse function which I have not discussed in the while discussing the solution, because it's very simple. We are passing the a vector, and then we are passing the first part of the element, that is 0, and then the last part of the element, that is end. And while reversing, we are moving from the first part and the end part, and we are just swapping these values. So if we swap these values, with this swap logic, and then increment initial index and decrement the end index. So automatically our array would be reversed. So this is very simple. And this first, when we reverse the first n minus k and then reverse the last k elements, and then when we reverse the whole array, we get the required answer. That, for example, in this question, the array is given and k is 3. That means we are right rotating it. So this 5, 6, k, 7 comes in the beginning, and then this 1, 2, 3, 4 comes. So automatically this reversing gives us this result. We have discussed this already. So let me directly run this and see. Are the test cases getting passed? Yes, both the test cases are getting passed. So we'll submit this. Okay, we have got a runtime error. The runtime error is when the k is actually greater than the size of the element, then we get this error. So what we will do is we will check what is the. So in that case we don't need to return it, right? So if k is greater than nums dot size, if k is greater than n, then we will be returning the nums, this vector directly, right? But what if we actually should make this k is equal to k mod n, right? K should be k mod n. So if it is greater also, then also it is possible that it should be returned, right? For example, if there are 3 elements and k is 5, so 5 mod 3, that means 2 times it would be rotated. One time it would be rotated and there would be no change, and the second, so the remaining part, the remainder would be the value. So this part will solve our solution, will give us the solution. We can see this has passed. So let me know in the comment section how was the explanation, and see you all in the next video where I'll be solving the 17th question of the problem solving series. Jai Jinendra.